Hello, and today we're going to take a quick look at how to create a hexagonal nut. Fairly simple thing to do really, but has a lot of implications later on, especially if you're trying to do something more complicated. So we're just going to start off by doing our extrude on the top plane. So what we're going to do is we're going to use this little sketch tool here. This is called polygon, and what polygon allows you to do is to create a multi-sided sketch where all the lengths and angles are the same. So the length of each side and the length and the angle in each corner is the same. So it gives you that sort of equal shape. Now this covers anything from a triangle with 3 sides where all the angles are equal and all the side lengths are equal, all the way up to hexagons, octagons. It can do, I believe, up to about 100 sides. Now at that point it pretty much looks like a circle, but that's beside the point. So all you have to do to do that is just change the number of sides here. Now we're going to use 6 sides obviously for a hexagon. Now do this, you start with the center point. So you can click on our origin because it needs to be central. We pull out for it. Straight away here you can see that you've got the hexagonal shape. Okay, and just drop it. There we go. So we've got a hexagonal sketch. Now the clever thing about this, of course, is because it's locked to the middle, it will now get bigger and smaller quite happily, stay to the middle, but it also will rotate or pinwheel. Okay, so it just spins around. Now because hexagons are clever, polygons are clever, basically means that this guide circle in the middle is all the dimensions you actually need to give it. So if we dimension this circle here to 18, okay, that means that the diameter is 18, the across faces value is 18 because it's the distance between faces, and because the angles are all the same and it always touches against this circle, it means that it's 18 between every set of faces, all the angles preset. So that's now fully defined. Problem is, of course, it's not fully defined. SolidWorks tells us it's underdefined and that the sketch lines are still blue. So what we need to do really is stop it pinwheeling, because it no longer changes shape or size, but it just pinwheels around. Now this isn't too much of a problem if you're doing something simple. Where we're going to get something a bit more complicated later, it will make a lot of difference. So what we're going to do is we're going to use a center line from the origin point just to one of the corners. Okay, so that now acts as our guide, doesn't it? So that stays like together, and I'm going to make this vertical. By making that vertical, that line has basically given the final bit of definition to this hexagon. It's stopped it pinwheeling. So that's nice and simple. We'll do then just end our sketch as usual. Give it a thickness. Let's do this 10, nice and simple. Okay. So there we have our hexagonal block. Now, if we're making it into a nut, it's nice and simple. Use Hole Wizard because it always makes life easier when we're doing threaded holes. Do straight tap, metric, bond tapped, hole size M12, and we can go all the way through. That's okay. Hit position, clip face, on the top. Now looking at that, that's put a countersink on it, which I don't want. So let's just go down here. There we go. So we need to just take the countersink off here. That's better. Tick that. There we go. So we now have our threaded hole. You can tell that by the fact it's got the extra little thread line around the outside that comes with saying hole thread. We can just go back through the options, document properties, detailing, shade our cosmetic threads, and then hit OK. There you go, that shows it's done. Now this is a very simplistic nut. If we're looking at something a bit more complicated, we know that we basically chamfer off all of these corners because they would be weak points. Now the easiest way to do this is actually to do a revolved cut, and what we're going to do is we're going to put a revolved cut on this right plane, because the right plane cuts through the tips, and that's because when we did our hexagon we locked it to the vertical. Okay, so that means that those tips will now go through that plane, which is perfect for what we want to do. So let's normal 2, so it spins around. Excellent. Do a revolve cut. I'm going to quickly throw a center line in the middle. There we go. And then I'm going to use a normal line tool to basically draw the chamfer that I want to cut away. So I want to cut just sort of on here. You need to make sure you don't select the midpoint, otherwise you lock it in. So just select somewhere on the line, somewhere on this line down here as well. Close it out, because I want to do the same top and bottom. Just going to do it like that. There we go. Now I want to do the distance from the center to the tip of the triangle. That basically wants to be my radius. So when we did the original hexagon, we did an 18 diameter, so now we want to do a 9 radius. And what this basically means is when it spins round, it will just follow the line of that circle. In fact, we'll explain that a little bit more in a minute. Typical angle for this sort of chamfer is about 25 degrees. So we'll do the same down here. I'll be lazy because I don't want to measure it again. Click on that point, hold control so you select that point as well. So you've got 2 points there, you want them to be vertical. There we go. So that locks them together. Okay, so I've got both of those sketch triangles. I've got my centre line. So then when we move forward, when we do a revolve, it should automatically work out what I'm doing. There we go. And what we can see when we look up here is that it's going to cut just that shape round. Now at certain points, it basically is cutting nothing, because that's where the face touches, but then the other rest of the time it's taking off the tips of the corner. So if we just tick that, there we go. So we can straight away see when we look at it from the top, it basically looks like that guide circle again, doesn't it? So it's just, that's the diameter, so it's the across face value, and then you've just got the tips taken off of the corners, which means it should be a lot stronger shape. It won't get the same sort of error in the corners. Okay. So that's the basics of how to create a nut in SolidWorks. Thanks for watching.